Hello everyone, welcome to my YouTube channel. I am Shahab, and in this episode of Inside Out Roslyn, we want to explore diagnostic suppressors. In the previous episode, we have seen that how one could disable or suppress diagnostic analyzers reported by the compiler. Also, there could be diagnostic analyzers that is written by other developers, and they are injected into the compilation pipeline and reported by the compiler. However, those were static. It means that we could either disable it or enable them. In this episode, we want to explore a more dynamic way. It means that the compiler could decide in certain scenarios based on the condition whether to suppress a diagnostic or not. So, if you're also interested, stay with me and let's dig into it. Consider we have a game events class and we marked that as an abstract and we created it with a private constructor. This means that no other class outside the scope of games events class can inherit from it, and also no one can instantiate an instance of this game events class. What does that mean is that the game events are restricted to the classes that we have in here. So why this is important? Let's move a little bit up to the code that I have. Now consider that I have this game class which has an apply method. It accepts game events, and then based on which type of event it is, we are doing some different actions. That is where we have these switch expression. But as you have already noticed, there is a red squiggle in here, and what it tells us is, if I hover over it, it tells us that the switch expression does not handle all possible inputs. It is not exhaustive. For example, the pattern underscore is not covered. But we know that the game events class cannot have any other branches as game created, player joined, game started, and game finished. There is the only possibilities that we have is just these four classes. If I add the underscore in here, you will see that the error will be gone because now the compiler thinks that all the possible branches are covered while we don't have any other extra branches. This is always not called. So I hope you understood the problem space. Of course, I could come here. I could tell the compiler to, for example, disable this with pragma. But what if I accidentally not cover all the really all the branches? So now it is not complaining anymore. So I need to remove this again, like to be able to see whether everything is covered or not. And actually not. If I want to generate type patterns, you will see that here we don't have the game started covered. And if I add that, even though I have all branches that this switch expression, all arms that this switch expression should handle, but still it thinks that one is missing or potential other branches are missing. What we want to do today is to write a diagnostic suppressor that reacts to this diagnostic analyzer CS8509, and it checks whether the event instance that we have here is of a certain type, which is here game events, right? And it will check whether all the branches are the same as all the nested classes of these games events that are inheriting from it. And if it is the case, it will suppress this diagnostic. If it is not the case, it just do nothing. Let's go and explore it. So I have already created a switch expression analyzer class, and I will walk you through what needs to be done. So the first important thing is that the diagnostic suppressor, if I go to its definition, you will see that it is also a diagnostic analyzer. So it is a special diagnostic analyzer in which the supporting diagnostics in here is an empty array. If I just scroll a little bit, you will see it is an empty array. So it is not reporting any diagnostic. It has two abstract members that needs to be overridden or implemented in the inheriting classes. One of them is the supported suppression that returns an immutable array of suppression descriptor. The second one is report suppressions method that accepts a suppression analysis context, and within this context we could report a suppression for a diagnostic analyzer. Let's go into our diagnostic suppressor and see how I have implemented this too. So I have created this switch expression analyzer. It is inheriting from Diagnostic Suppressor. And to properly implement supported suppression, currently it just returns an empty array, which means it doesn't suppress anything. We need to create a suppression descriptor. For that, we need a couple of information. The first thing that we need is a diagnostic ID that this suppression is going to react to. And as we saw earlier, it is CS8509. And then it also needs its own ID. So we need like to provide a suppressor ID. I just named it SP8509. And then also a justification. Let's say this class is abstract with private constructor and all branches are covered. With those information, we could create a suppression descriptor. If you remember, this is the similar pattern for diagnostic analyzers. We have also a diagnostic descriptor. We have some meta information that we need to pass to that descriptor. Here is basically the same pattern. We are passing the suppressor ID, the diagnostic ID that it is covering, and some justifications to be shown later on in the IDE and other tools. So what I need to do now is I need to put it inside this array. So we're saying this is the rule that we are supporting. The next step is to implement the report suppression. I have already implemented the logic that covers the basic scenarios for these things. You could check that in the repository by yourself. I'm not going through all the details. Basically, we are using sharplab.io to analyze the syntax tree. This is already covered in previous episodes. And then based on those meta information from the syntax tree and semantic model, we are deciding whether all the switch arm expressions are mapping to the nested inherited classes of these games events class, for instance. Things that are important here is that always check for the cancellation token and stop the operation if it is already requested to be canceled, because we don't want to process further if the user is already covering, for example, other branches of this scenario, right? The next important thing is that the context that is passed to this report suppression has a property called reported diagnostics, and it's plural, because it could happen that the same diagnostic is reported in multiple locations, and the compiler calls this suppressor once with the list of all of those diagnostics. And then we need to iterate through all of them and see which one should be suppressed and which one should not be suppressed. And this is what we are doing. So in this can skip reported diagnostic, I'm just checking for the scenarios and the conditions for these reported diagnostics. And then in suppress reported diagnostic, I'm passing the context and the reported diagnostic. Let's just take a look into that method. Here, what we need to do is using the suppression class to create a suppression for the reported diagnostic and assign the suppressor with this rule that we have defined on the top. And then we are telling the context to report this suppression. So this diagnostic ID will get a suppression, and then we know that this, or the compilers knows that this needs to be suppressed and should not be reported as a warning or as an error. Let's go and now reference this analyzer project that we have in the actual use case that we are having and see how it works in action. Now, if I am going to my sample.console where I have this game.cs, right? You see that here I have two methods, the same things that both of them are reporting the same diagnostics. So my suppressor will get a list of reported diagnostics, which contains two items or two elements in it. Referencing the diagnostic suppressor is the same as referencing the code analyzers or diagnostic analyzers. You're adding a project reference or a NuGet package reference to the analyzer, setting the output item to analyzer and reference output assembly to false. And now if I build this project. We'll see I don't have any errors. If I'll go there, the errors are gone because now the suppressor is reporting that this diagnosis needs to be suppressed. If I just removed one of those branches, you'll see that the diagnostic is again back, because actually now we expected 4 switch expression arms, but we have 3, and the types are not matching with everything that we had. So, and this is where we need to act and do not suppressing this diagnostic analyzer. I could use the underscore branch to make it work, or I could just add the missing part and it will still be gone. Let's close these projects and open the tests. I already have switch expression analyzer. I wrote some tests for that. For example, when all cases are covered, then do not report a diagnostic. And this is the scenario that we have. And here we are expecting it with location 0, which is marked in here. This is where we marked. We expected in this location a diagnostic to be reported, but that diagnostic that is reported needs to be suppressed. So we expected a diagnostic, but we also expect that this diagnostic is suppressed. This is very important for us. And the rest of the code is the same as testing diagnostic analyzers. As I already mentioned at the beginning of the course, Diagnostic Suppressor is a diagnostic analyzer. So let's just run all the tests. Okay, 2 of them passed. The ones that are passed are the ones that do not suppress the diagnostic, but the ones that are suppressing the diagnostic, they are not passed. There is a system.type initialization exception happening in here. And this is because the way that the testing library is working behind the scene has been changed in the versions that we are using. Let me just show you the versions that we have. So if we go to the test project for the diagnostic analyzers, we are using Microsoft.code analyzers, C#.analyzer.testing, and the version is 1.1.2, which is the latest version, but it is not compatible with diagnostic suppressors when they are reported. To make this work, we need to add a NuGet feed. So I'm going here, I'm adding this NuGet feed. After adding that NuGet feed, we could go to our project and we could change the versions that we need. So 1.1.3 beta 1 is like the version that I'm going to add. The same for code fix testing, even though we're not using that at the moment. So if I go now in here and now just run all the tests again, you will see that this is a result and all the tests are passing. Great. So far, we learned how we could disable or enable diagnostic analyzers, whether through some configurations like the editor config or using the preprocessor directives like pragma, enable, disable, or we could use the diagnostic suppressors to have a more dynamic behavior. What do you think? When we should use each of them, and what's your opinion about that? Leave me a comment below, and as always, enjoy coding and damn it,